Assalamualaikum warahmatullahi wabarakatuh. Hello, mate, and my fellow students, and also any academicians in my campus. In these occasions, we will talk about the thermodynamics in nuclear reactors. This was one of the thermodynamics course assignment. So henceforth, let's go. I'm here with my partner. Let me introduce myself first. I am Sulaeman Daniswara Mulia Putra with the NPM 33341900063.
And I, Firman Ramadhan, with the ID 33341900037 as the second presenter.
Okay, here's our content. We have two main topics. The first one is technology and process, and the second one is thermodynamic aspect and involvement. So basically, the technology and process is divided by each particular part. First one is principles and material. Second is how does it work. The third one is product, and the last one is related industries. Before talking about nuclear energy and nuclear reactor, we should know what these both mean in definition. Therefore, the nuclear energy, also called the atomic energy, is the energy that is released in significant amount in process that affect atomic nuclei, the dense core of atoms. The one method of releasing nuclear energy is by control the nuclear fission in devices called the nuclear reactors. Why these nuclear fission and nuclear reactors are marked with the red ink? Because it has their relations insist, and we can know in the next slide. So basically, nuclear energy is the energy consists in the dense core of atoms. So the nuclear reactor is the one of the tools or method to extract the power within the dense core of atom into another uses like electricity or something like that. So here's the founder of the nuclear energy itself, the Enrico Fermi, an Italian physicist and scientist. He created the experimental breeder reactor 1, or can be abbreviated as EBR1, in December 20, 1951, established in Chicago, USA. So he created this method due to the nuclear advancement post World War II and in the Cold War. So he think that is it any probabilities to change the nuclear uses rather than explosive and lethal weapon into something useful like electricity and something else. So he created the EBR1 in order to support their research with. So in particular, nuclear has its own method to extract their power or their energy within it called the fission and fusion. And what is the difference between each both? We can see in the next slide. So before we went through that, here's the common material used in nuclear reactors. The first one is nuclear fuel uranium, which is commonly found in many reactors in nowadays. The uranium occurs in several slightly differing forms, also known as isotopes. Natural uranium can, as found in Earth crust, is a mixture largely of two isotopes. So, in briefly, isotope is the another kind of uranium which consists among different of proton and neutron. And in the left side, we can see the atomic number represent the proton, and the neutron is the subtraction between the atomic weight and the atomic number. So the difference between each uranium, is the difference of its proton, its either proton or neutron exists. So the common, in the Earth crust, we can find only two uranium isotopes. The first one is uranium-238, which accounted for 99.3%, and this one is tend to use for fission experiment, still being developed. And the other side is uranium-235, which among 0.7%, and this one already implemented in fission reactors. So I want to emphasize again, we are talking about nuclear reactors, so we are talking about the fission. Therefore, the uranium-235 can trigger the fission reactors, but it has a few amounts of existence in Earth crust. In other side, the uranium-238, which is larger and lighter, but this one is cannot be used to trigger the reaction. Why could be that? And here's the reason why this happening. So if the uranium-235 is fissile, that of uranium-238 is said to be fertile. So the difference between fissile and fertile is fissile is the ability to trigger the reactions of fission, and the fertile itself is the opposition of fissile, which is cannot be used to trigger the reaction of fission. So this means that it can capture one of the neutrons which are flying about in the core of the reactors and become indirectly plutonium-239, which is fissile. Thus, briefly, we can conclude as the uranium-235 is fissile, so they can trigger the fission reaction and it could make heat, and we convert heat into the energy. Therefore, uranium-238 need to capturing neutron first and becoming plutonium-239, which is fissile, and henceforth it could make heat and then convert it into the energy. So, in addition, the this phase start from capturing neutrons until becoming plutonium-239 is require a lot of calculation, especially in temperature and pressure, and also some initiating energy and treatment. Here's the principles among the fission and fusion. So, fission occurs when a neutron slams into a larger atom and triggering plus one neutrons, forcing it to excite due to its unstable conditions and split into two smaller atoms, also known as fission product. And the fusion itself, it's occur when the two atoms slam together to form a heavier atom. So, in this presentations, our concerning about is the nuclear fission. So this one marked with the red bar, and we are focusing about the neutron slam the uranium-235 and it become the uranium-236, and due to its instability, uranium-236 is excites particular large of atoms, and these atoms is conduct the fission, and therefore henceforth this name as fission product. So in the left side we have two of tables which represent the advantage and disadvantage of each both. So starts with fission reactions, and any of these word marked with the black ink is represent the merits, and any of these text marked with the red ink is represent the demerits of it. So the fission reaction provide unlimited fuel and simple to control. However, it have expensive construction costs and high risk of radiation exposure. In other side, the nuclear fission reaction is clean and alternative source of energy, and it has extremely low operation costs. But it have high vulnerability and little understood and still being researched. So, in addition, the yet fusion reaction are being studied by scientists and isn't yet being implemented. Maybe in the future, there's a probability in the future the fusion could establish in particular country, an advanced country like USA or maybe in Japan and anything else. And this is the mechanism of it and how does it work. So we have two of colors here. The first one is the orange, which represent the primary, either steam or water, and the other side is represent the secondary inside this blue tube. So the first is fission occurs within the vessel by control rod, heating up the primary water among 300 Celsius and create primary steam. The secondary water inside the steam generator boiling due to extremely continuously heat from the primary steam. And after that, the boiled secondary water becomes secondary steam, and the steam moved turbine to generate electricity. And after that, water went back to steam generator's vessel after being condensed in condenser. So here the concern about again, nuclear energy is a renewable energy, or rather to be said as sustainability energy due to its low probabilities of damage circumstance, sustainable and continuous ability to provide electricity with extremely high potential.
Now, for the industrial end, the nuclear reactors are being used only to be a power plant. There were some countries that already use PWR model, such as China and USA, which the model of reactors are AP100. In Indonesia, you can see here, Indonesia National Nuclear Energy Agency or Banten already using the reactor for research purpose, where the reactor is placed on Serpong. Now we move to the thermodynamic aspect and involvement. In works, efficiency is the most important thing. In the reactor, we need to make sure about its thermodynamic efficiency. So the first thing, the water temperature must be increased to 300 degrees Celsius, not 100 degrees Celsius, because the thermodynamic efficiency is not stable. And the second one, applying high pressure in the reactor vessel. Why? It's because to prevent water from boiling. If the water boils, there will be potential for evaporation. So we need to make sure to applying high pressure in the reactor vessel. As you can see here, is the equation that happened in the reactor. Next, for the phase diagram, we use uranium oxide system as its fuel. The reactor contains 100 tons of uranium as its fuel to heat up the primary water. If you see here, is the liquid area, liquid phase from the system, which gives energy of respectively pure uranium oxide, uranium, and fictitious oxygen liquid phase. The ionic two sublattice model was adopted for the description of the liquid, with one sublattice for cation and one for the anions. And next, here the area for the gas phase. Here, area here. And the gas phase is described as an ideal mixture containing the gaseous species such as uranium, oxygen, O2, O3, O1, U1, O2, U1, and O3, U1. As you can see, the Gibbs energy of the gas phase is given as here. Which you can see Yi and Gi gamma. The Yi is the mole fraction of the gas phase of the species I in the gas phase, and the G represents the standard Gibbs energy of species I of the gas phase, and the R is the gas constant, T is the temperature, and the P0 the standard pressure here, the P0. So it's the fuel system. We use uranium oxide for the reactor fuel. What in conclusion, the pressurized water reactor system uses uranium oxide as its fuel, where the thermodynamic involvement for the nuclear reactor is the reactor need temperature to heat up the primary water until 300 degrees Celsius. So that's all from our presentation. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.